Okay, let's look at the section 10.2. This section talks about denumerable sets, countable and uncountable sets. All right, so let's look at the definition of denumerable sets. All right, so set A is called the denumerable if set A has the same cardinality as the set of all natural numbers. Right? So this is by definition, we know that there exists a bijective function f from set of all natural numbers to the set A. Right? So it has to be 1 to 1 and it has to be on to at the same time. Right? If you have this function, you can see that the 1 is going to be mapped to an element of A, 2 is going to be mapped to element of A, 3 is going to be mapped to element of A. We can make a list of elements of A. So A can be written as, all right, f of 1, comma, f of 2, comma, f of 3, comma, and so on. Right? More simply, we can actually just say, if you have a denumerable set, the characterization of a denumerable set is that we are able to list all the elements in this fashion. First element A1, second element A2, third element A3, and so on. Right? So this is a very useful characterization of a denumerable set. All right. All right. So also let's look at the countable and uncountable set. All right. Countable set is either finite set or denumerable sets. So these two guys combined, they're called countable set. Because in a way, we can count the elements. Denumerable set, there are infinitely many elements, but still you can list the elements in this fashion. All right? Then all others, so if it's not finite and not denumerable, then they're all uncountable. All right? All right, so let's look at an example. All right, let's look at the set of all integers. All right, is it countable or uncountable? All right, so as it turns out, this is a denumerable set, which means that it's a countable set. Let's see. All right, remember the characterization of a denumerable set. If you can list it as the first element, second element, third element, and so on, then it is a denumerable set. All right, set of all integers. Let's try to list it. All right, let's start with 0. So 0. All right, next one is probably 1. Next one is -1. Next one would be 2. And -2. 3. -3. And so on. We already see the pattern. All right, since we are able to list it in this fashion, we know that set of all integers is denumerable, right? Right, which means that this is a countable set. All right. And another example is uncountable one. Later in the section or a chapter, we will be able to show that we will not be able to list the element of all real numbers, like real number 1, real number 2, real number 3, and so on. All right. We will be able to show that this is impossible. Right. So therefore, and we know that set of real numbers, it's an infinite set, so it's got to be infinite. And at the same time, it cannot be listed this way, which means that it's not denumerable. All right, which means that this set is uncountable. All right, so those are the denumerable sets, countable set, and the uncountable sets. All right, I hope that this was clear.